Okay, let's try this. Instantaneous rate of change is derivative. And let's just write down what this means until we get the fast rules. What is f of x plus h? Well, plugging x plus h in instead of x in 1 over x, and the original function is 1 over x. Okay, so a little note. I think just for fun, I'll do it at the beginning. Let's see. And then also, second note, the compound fraction trick. Okay, so common denominator is 3 plus h times 3. Multiply the first fraction by 3 and the second fraction by 3 plus h, and subtract properly. Distribute properly. And notice you have a negative h, not an h. Canceling the 3's out, and then canceling out an h. We have negative 1. And then once you've factored and canceled h, you can let any remaining h's go to 0. Okay. So we're trying to motivate a second definition of the derivative. So I'm just going to make a little note. This definition in the textbook, this is called definition 5. Right, secant line is a line crossing between 2 points. So we do our standard rise over run, not derivative. Let's see, y2 minus y1 over x2 minus x1. And that's all we can do because they didn't give you a specific function to mess with. The tangent line, the instantaneous rate, and we could do this with h's, but second definition of the derivative is to take the limit as x gets closer to its value. And this is called the alternate definition of the derivative. And in the book, it's called definition 6. Okay, so a little note about it. It gives something that the x eventually has to turn into a 3, so we only get a single number, not a formula that you can plug other numbers into. So f of x plus h minus f of x. Subtract properly. Put a little note. Okay, so this regular definition gives you a formula that you can plug numbers into. So okay, next. Alternative definition. We need to know a is 3 here. And let's just figure out what g of 3 is. (18 plus 6 is 24. So what we have is the limit x approaches 3 of, I'm going to use x's, what the heck. Oh, there's a lingering x minus 3 if you factor it all out. Remember, the goal is to factor and cancel an x minus 3. Ugh, that was a terrible exclamation point. Hold on. Okay, let's find the derivative using the regular definition. The function was, oh yeah, 2t plus squared plus x. Okay, so 2. Not 6. Okay, so this definition of the derivative works for any a's. And again, I can plug the a in at the beginning or the end. Maybe I'll plug in the a at the beginning again. X plus h? No. A plus h. At the, oops. Okay, all the x's or t's or whatever have to turn into a's. So okay, that's my formula for taking the derivative. Now I can plug in numbers. If I want to find the slope, derivative at a single point. 2. Oops, why do I have a -5? Oh, hold on. I refuse to, I'm gonna, yeah, let's see, 5 H's, that's 5, that's a +5. Okay. Oops, fix it. Okay.